This video is about electricity graphs that can come up in P2. So last year you were given a question like this and you were asked to find out which one had the most resistance, and a lot of people went for A and it was in fact C. This is a fixed resistor. We know it's a fixed resistor because the resistance is always the same, because the gradient wherever I have on line A would be the same. So for these it's a fixed resistance. Now resistance is potential difference divided by current, okay? So this one in fact has the largest resistance. So here we have a filament lamp, and they do love to talk about this one in a bit more detail. So they may talk about how at the beginning it is sort of proportional to the current going up and the potential difference going up, and it will start to level off and the resistance will start to increase. And that's how you recognise it's a filament lamp. But they might ask why the resistance starts to increase. Well, this is because a filament lamp is made of a metal. Now, as you increase current, you're giving it more energy, so the metal ions inside of it will start to vibrate more, okay? So as they start to vibrate more, it's going to be a lot harder for the electrons, which is the flow of current, to actually get through. So the resistance is increasing because resistance makes it easy or hard for the current to flow. I always liken it to a corridor. If you had people in a corridor and they're all lined up in nice rows and you were walking through them as a teacher, it's a lot easier to get through them standing in rows when, say, the metal filament is a bit colder because it's just been switched on. However, if they're a bit chaotic and they're running around everywhere, it's a lot harder to get through, and I liken that to the metal ions having more energy. So here the temperature is increasing because the resistance is increasing because the current's increasing. An LED or a diode. Now both the graphs look the same because they are both diodes. Now diodes only let current flow in one direction, which is why here it's almost zero, and until it gets to a point it will actually start to increase. So if you get a graph like this and you have to label it, it is a LED or a diode depending on which option they're giving you. These are the symbols for them. Light is emitted through a light emitting diode when electricity goes through it. We use it for a lot of our things today because it's a lot more efficient than, say, this. This is totally inefficient. It lets out so much heat, which is so much waste energy because you want light. So we do use a lot of LEDs today. LDR is a light dependent resistor. All resistors have this little rectangular box, okay? I think of this like a lamp and light's going in. So it's light dependent, it's resistance dependent on its light. Now this isn't like the other graphs, which are actually what we used to call IV graphs, current potential different graphs. This is slightly different. This is showing you light intensity increasing and the resistance is increasing, okay? So for low light intensity, the resistance is high, whereas when the light intensity gets higher, the resistance is lower. Now this is because LDRs are made up of a semiconductive material, a little bit like solar cells. So when they get some light energy, it starts to excite those electrons. The electrons start to flow. If electrons are flowing, we're not having resistance, so the resistance is quite low. Thermistors are exactly the same as LDRs because the principle is exactly the same, apart from as the temperature increases, the resistance decreases. And this is again because they're getting more heat, so it's causing the electrons to get more energy, start to flow, so resistance is low. Again, thermistors have this rectangular box with I call it like a little hockey stick going through it. I hope those help.